Hi, I am Burak. I recently graduated from Istanbul Technical University Satellite Communication and Remote Sensing Master's Program, where I successfully completed my master's thesis under the supervision of Professor Dr. Elif. Now I will be presenting my thesis in a short and concise way. This is how I will be proceeding today. The thesis focuses on image segmentation task for high-resolution land-use-land cover mapping of diverse and complex classes using multi-modal and multi-task deep learning frameworks. And the novelty of this thesis is twofold. The dataset used in this thesis is created from scratch for the task of pixel-wise land-use-land cover classification, and contains two modalities, optical and SAR, acquired from Spot7 and TerraSAR-X satellites, respectively. 14 Korean-like classes are used during ground truth creation phase. Given the challenge of creating pixel-wise annotations, we adopted a weak labeling strategy where semantically similar and spatially close objects are assigned to same label. We believe this weak labeling strategy is a suitable approach for two reasons: the nature of satellite imageries in terms of very high resolution and similarity in spatially close objects, and real-life scenarios where label noise is unavoidable. The methodology section could be categorized into two groups, multi-task learning and multi-modal learning. In the MTL part of the experiments, auxiliary tasks have been implemented to improve the main task performance in a unified learning scheme, benefiting from common hidden representation. MML part of the experiments, on the other hand, focuses on investigating the possibilities and challenges of combining optical and SAR modalities. It's almost unreal for a single modality to capture the entire rich characteristics of the area of interest. Here we focus on data fusion part of the MML and investigate the ways of fusing two modalities. The assumption is that data fusion provides valuable hints that are lost if these connections are not established. Three experimental setups are conducted: early fusion, middle fusion, and late fusion. In MTL, on the other hand, several tasks are simultaneously learned by a unified learner. In these experiments, we propose to couple the main segmentation task with two auxiliary tasks, boundary extraction and image reconstruction. The reasoning behind this is motivated by one of the main challenges in remote sensing pixel-wise image classification, poor boundary delineation of objects. We argue that coupling the main task with image reconstruction and boundary extraction tasks will help the classifier better delineate the boundaries. One common problem in MTL is to combine loss functions. As can be seen here in this graph, it's challenging to tune these individual loss weights. To this end, instead of manually tuning them, we adopt the homoscedastic uncertainty-based logic to turn these loss weights into learnable parameters, which are then learned throughout the training process. Here in the slide, scientific outputs produced directly or indirectly from the thesis are shown. The MML experiments conducted in this thesis points out the importance of fusing multiple modalities in a unified deep neural network. Although some fusion techniques harms the overall performance, such as middle fusion and late fusion, it's possible to conclude within the light of the experiments conducted. Early fusion further increases the plane segmentation tasks in performance. As for the MTL one, it has been found that it's possible to harness from common representation by simultaneously learning reconstruction and boundary extraction tasks, along with the main task in a unified learning scheme, resulting in an observation that land cover segmentation task shares common representation with image reconstruction and boundary extraction tasks. The techniques introduced in this thesis allows fast and fully automatic generation of accurate segmentation maps without human presence. These results could be beneficial in numerous disciplines for numerous real-life scenarios such as urban planning, risk and crisis management, and environmental policies. As a result, we believe that conclusions made in this thesis provides regional and global stakeholders, NGOs, policy and decision makers with more informative segmentation maps. This thesis is supported by TÜBİTAK under the scholarship program in the priority fields in science and technology. The TerraSAR-X image delivered by German Aerospace Center, and the Spot7 is delivered by Airbus through ITU CSCRS. Thank you.